Hi, my name is Patrick Fow, and I'm a student in the M3PL lab here at UW-Madison in the Department of Mechanical Engineering under Dr. Frankie Pfefferkorn. And today I'll be talking to you about optical microscopy and measurement and how we use it in our lab. So to start off with, what is a microscope? A microscope is simply a tool used to magnify the view of small objects or items, and this is done through glass lenses usually. And what you can see with the image on the left, that's just a simple magnifying glass where as a kid you might have looked at a bug, for example. But either way, it allows you to view much smaller objects than what you could with your eye. And this is a very simple microscope, being a magnifying glass, just has one lens. And what you can see here on the right is a more common microscope that's found in labs. And what you can see is that on the left, they have a light, and then they have an eyepiece here up top, and then that all shines down towards the optics, where you actually set your sample down here on this black plate, and you have optics where you can choose your magnification, and you can observe whatever you want to look at that's too small to view with the naked eye. And here in our lab at UW-Madison, we have a variable focus microscope, and it's the model is a Alicona Infinite Focus G4. The microscope head holds the camera and the optics. The optics below here are 5 times, 10 times, 20 times, 50 times, and 100 times magnification, and we can choose between either of them. And what this microscope allows us to do is we can set our sample on an XY table, and that allows us to move both front and back and left and right. But also we have another range of motion, which is in the Z height, and being that the actual microscope head can be moved up and down and to get the optics into focus. And so so we have 3 dimensions of motion on this machine. And what you can see here is the basically the minimum vertical and horizontal resolutions that we can obtain with this microscope. As you can see, they're very, very small, much smaller than a human hair for the vertical resolution, for example. So I'll run you through a basic sample experiment, and here we just have a blank sheet of paper. We took one pencil and wrote a straight line, and then we took a pen and wrote a straight line as well. And what we did was we observed the pencil line and the pen line at these individual spots. And so using our microscope, we were able to observe the two lines. And what you can see is that for the liquid ink on the pen, you can see when the liquid ink hits the paper, it wicks along the actual fibers. So what you're seeing here is actually the fibers of the paper, and the ink sitting on top of it or wicking along it. And so as you can see, when the liquid ink hits the paper, it spreads out and it goes along the fibers. It wicks similar to a candle wick, for example. Whereas for the graphite on a pencil, it's breaking off in chunks and smears on the paper as you drag the graphite along the paper. So you can see that the graphite has distinct lines in the same direction as the line itself. And this is due to the actual smearing and breaking off of the chunks of graphite as you drag it across the paper. And what you can also notice is that you have for the graphite that you don't have for the pen is that these little chunks on the outside of the line, these are simply splatter from when the graphite was breaking as it was dragging across. And if you've ever had a dark mark on your hand after writing a lot on a piece of paper with pencil, that's usually associated with these little particles breaking off and sticking to your hand. And so how do we use this to So that's the end of our sample experiment. And now, how do you use this to measure real surfaces? So basically, our microscope has a focus range. It takes if our sample is in this box, basically we are able to see it with our lenses. And so one thing to note is that this is a defined range. There's a max and a min value that you can actually be in focus. And that's actually observed here, as you can see that for some portions of this image, you can see the fibers perfectly well, but they're blurry for other areas. And that's simply because they're at a different height in the Z range. So a different height in the focus range, which means they're starting to become out of focus. They're not at the point where we can actually see it most clear. And so how do we use that? So basically, we know that we have a Z control on our microscope, and it can control the height of the microscope up and down, and we can move this in very small increments. And so basically, you can imagine that if we took an image of the same location at various z heights, we would have different parts of this image be in focus at a time. And what they can do is the software in the computer can combine all that and make a real surface, which an example of which is right here, which is actually just a rough metal surface. But what you can see is we can actually get the full detail, the XYZ of a sample surface simply by measuring it with a microscope at various heights and the software piecing it together. So this is very useful in our lab as we use it for nearly every experiment that we do. We, in some way, shape, or form, end up using the Alicona to either look at things or you can actually measure stuff to very high precision. And so that's just a basic overview of the Alicona and what we do with it in our lab. And this is the end of my presentation. So thank you for listening.